First thing to do would be to start creating our segments.
Yeah, so we're going to divide this from 1 to 2 by 4, what, subintervals, right? So this middle point between 1 and 2 is what? 1.5, do you see that? Right? And then between 1 and 1.5, this is what?
1.25.
1.25. And between these 2 points, we have what? 1.75, right? And then by using these 4 subintervals, we can get what? 4 rectangles, right? Here we're going to use what? Right end point as a sample point, right? So that means on this subinterval we use what? Right end point, we can get what? A rectangle, right? And then here, on the second subinterval, we use a right end point that gives us another rectangle. Third rectangle, rectangle number 4. This is by using the right end points, right? Okay, now I'm asking you guys, what is the height? What is the height of this rectangle?
No.
This is a function y equals 1 over x.
So it would be 4/5.
So 4/5. What is end point here? 1.25, right? So the height should be
1.25, then that is 4/5.
Yeah, should be what? The height of this rectangle should be 1 over x, right? What is x? 1.25. Do you agree with that? Yes, right? Yeah, okay. And then what is the height of this rectangle? 1 over what? What is this sample point? 1.5, right? What is the height for this rectangle? 1 over what? 1.75. What is the height for this rectangle? What is it? 1 over what? 2. Right? So I use R, which is a right end point, with 4 rectangle. R4 will equals what? Length, which is height, times by what? Width, right? So height is what? 1 over 1.25 times by, what is the length of each subinterval?
1/4.
1/4. Or we can get it by what? B is what? 2. Minus A is what? 1. Divided by how many intervals? 4 intervals, right? N is 4, right? N means how many intervals, right? Subintervals, okay? Or how many strips we have. So 2 minus 1 is 1 over 4 is what? 1/4, right? So times by 1/4 plus what? Second rectangle, what is the height? 1 over 1.5 times by 1/4 plus what? 1 over 1.75, 1/4 plus 1 over 2 times by 1/4, right?
What's the general formula for delta x again?
B minus A over N.
Thank you.
You're welcome. So now let's try to do it, okay? So this is 1 over 5 over 4 times 1 over 4 plus this is 1 over 3 over 2 times 1/4 plus 1 over, bless you, 7/4 times by 1/4, 1/2 times by 1/4, right? So 1 over 5 over 4/5, 1/4 plus 2/3, 1/4. 4 over 7, 1/4. 1/2 times by 1/4, right? So that will give us what?
1/5
1/5 plus what?
1/6
1/6 plus 1/7 plus what?
1/8,
1/8.
which is a suspiciously interesting sequence.
Yep. So can we find the least common denominator? From 5, 6, 7, and 8. It is hard, right? It is very hard. Or I would suggest that use a decimal number, okay, if you want to, okay? 1/5, what is that? 0.2 plus 1 point, this is point, what, 1/7? Yeah, get a decimal number.
I have a fraction if you want it.
Yeah, we can get a fraction, yes, we can, but we need to find the least common denominator, right?
Which is 840.
840?
Yes, which is 533 over 800.
Did you multiply all of these? Okay. Yeah, we can do it that way, but also to find LCD, we can do what? 5 can be factored by 5 times itself, right? 6 can be factored by 2 times 3. 7 can be factored by 7 times by itself. 8 times by 2 times 4. So LCD should equals 2 times by what? 3 times by 4 times by 5 times by 7. So it should be half. I don't know. 2, 3.
Professor, I already did have it.
You did have it. Okay. What is it? 6.
840.
840, right? Okay. So 6 times by 20 times by 7, 840. Yes, you're right. Okay, 840. Okay, so 840. So on the top, 1/5. Use 840 divided by 5, right? Give us the number here. What is it? 840 divided by 5.
I have a spare calculator if you want to borrow it. Okay?
Oh, that's fine. That's fine. I'm just saying that we could always do it. So what's the final answer eventually?
533 over 800.
533 divided by what? 840, right?
533, not 36.
533 divided by 840. Okay. Or this is complicated, just use decimal numbers, okay? And see whether WebAssign will take it or not, okay? Otherwise, they will have to rewrite each fraction to have an LCD 840 and then get this fraction. So that's good for by using the right endpoint to solve the problem. Now let's check on, if we're using the left endpoint to solve the same problem, okay, how? Another screen paper. Same question, think about it. Left endpoint this time, 4 rectangles. Still from 1 to 2. Okay, we're still having these 1.5, 1.25, 1.75. Now we're using what? Left endpoint, okay? So from the first step interval, we use a left endpoint. We have this rectangle. Second endpoint, this rectangle. They should have the same width, okay? Okay, so what is the width for each rectangle? Same. Delta x is 1/4, right? However, we need to recalculate what? The height, right? This height should be what? This is y equals 1 over x. The first height should be, I'm going to use L4, okay? So height for this rectangle should be what? 1 over 1, right? Times by 1/4 plus, what is the height for this rectangle? F of what? 1.25, which is 1 over 1.25 times by 1/4 plus what? Third rectangle, 1 over 1.5 times by 1/4, and then plus the last rectangle is what? Area should be 1 over 1.75 times by what? 1/4. You guys? Alright. 1 over 1 is 1 times by 1/4. This is 1/4 plus. This is 4/5 times by 1/4. This is 1 over 3/2, 2/3 times by 1/4. 7 over 4, 4 out of 7, 1/4. We did it previously. Ooh, look at this one. 1/4 plus 1/5 plus 1/6 plus 1/7. Okay? 1/4, 1 over 5, 1 over 6, 1 over 7. You guys? What is the LCD this time?
420.
420? Would you multiply this, right? So 67, no common factor, 42 already, right? 42 times by 5, what is it? 210, right? 210, but yeah, there's a 4. So use that thing, okay? 4, 2 times 2, 5 is 5, 6, 2 times 3, 7 is 7. So we're going to use 2 times 2 times by 5 times by 3 times 7. So LCD is what? 420, right? Yeah. So 420, what should we have here?
319.
3 what?
319.
319. Okay. So this is L4. Okay, L4. 319 divided by 420. Okay, we're not completely answered the question yet. Okay. We just did what? Just use the right endpoint and left endpoint to compute what? The areas, right? The areas for those 4 rectangles to approximate the area for this region S. Now question A, which we have already done from the part A, is this estimation by using the right endpoint underestimate or overestimate for question A? Underestimate or overestimate? Under, right? Because you see, these 4 rectangles are shorter, right? They're smaller, right? So it's underestimate for what? Part A, right? So underestimate, right? Okay, so in part B, do you think our estimation is underestimate or overestimate? Yeah, see these rectangles, they're taller, right, than this just region, right? So I would say overestimate. What do you think about this type of question on your homework assignments? Not bad, right? Not bad. Okay.
Tedious, but not bad.
Yeah. So it's not, I said it's not hard, but it is tedious. Okay. All right. So we're gonna have. What is the third part of the? Oh, we're gonna have another practice question. Okay, practice question. This is also like several steps. Okay, so I will work on this question with part A. Okay, I'll need you to do part A. And then you will do the B part and C part in group. Okay, in group. So, estimate the area under the graph f of x equals 1 plus x squared from x equals -1 to x equals 2 using 3 rectangles and the right endpoints. Then you prove your estimation by using 6 rectangles, sketch the graph and the rectangle. See, part A use right endpoints. I should need you to do the part C, right? Because part C we haven't done that yet, okay? Yeah, so I want you to try the part A by yourself, okay? Part B, repeat part A using the left endpoints. Part C, repeat part A using what? Midpoints. So let's do the part C together, okay? Eventually, you will answer from your sketches in part A to C which appear to be the best estimation. We'll see, you can answer the question, okay? Yeah, so either using right endpoint or using left endpoint or using the midpoint, which one is the best estimation? Okay, we'll see, okay? Alright, so let's do question C together. Let's draw the picture for y equals 1 plus x squared. What do you think about the shape of the function? Parabola, right? And path through point 0, 1. So when x equals 1, y equals 2, right? When x equals -1, y equals 2. Okay, when x equals 2, y equals what? Think about that. When x equals 2, 2 squared is 4, right? 4 plus 1 is 5, okay? So 3, 4, and 5. 5 is here. So when x equals -2, of course, it will be here, a point here, okay? However, we'll only talk about what? When x equals -1 to 2, okay? And then divided by x equals -1, x equals 2, and we're going to find what? Estimate the area of this region S, right? Okay, so first, using 3 rectangles, I would say 1, 2, and 3 rectangles, right? And in part C, what are our sample points? Midpoints means, we use what? This is our key point, right? What is the value for this key point? -0.5. This key point is what? 0.5. This key point is what? 1.5, right? Alright, so the height of the rectangle should be what? F of what? F of -0.5, right? So I would say I'm going to use M3, means middle point, 3 rectangles, sorry. So the height for this left rectangle is what? What is height? F of -0.5 times by, what is the delta x if we have 3 rectangles? What is delta x?
5/4.
What is the width, what is the length of this subinterval? Height is f of -0.5. What is the width or length of this subinterval? What is it? 1, right? Or, see here, delta x, we can do it by here. B, which is 2, minus a, what is a? -1 divided by 1. 3 rectangles, right? 3 over 3 is what? 1. Or you can tell, right? It is 1. Plus, now, midpoint is here, so when you draw a rectangle, it looks like this, right? So height is f of 0.5 times by 1 plus midpoint, when you use this. Okay. What is the height here? F of what? 1.5, right? Times by 1. Yep. And then, what else is f of the values? 1 plus what? -0.5 square times by 1, right? Plus 1 plus 0.5 square times by 1 plus 1 plus what? 1.5 square times by 1, right? So it will give us 1 plus, what is -0.5 square? 0.2 square, right? Times by 1, I don't write it. 1 plus what? 0.25 plus 1 plus, what is 1.5 square? You guys get the same answer? Okay, so add up everything. 1 plus 1 plus 1, 3. 0.25 plus 0.25, 0.5, right? 0.5 plus 2, 0.25, this is 2.75, so eventually 5.75, right? How about if we're using 6 rectangles, still using the midpoints? Let's redraw a picture. I want to draw a bigger picture for us. Wider. Just -1, 0, 1, and 2. This time, we'll have how many rectangle? 6, right? So -0.5 is not a key point, or it's not a sample point in the interval. It is actually an end point for a subinterval, right? This is 0.5. This This is 1, 1.5. Alright, so we have this 1, 2, 3, 4, 5, 6. 6 strips. But these are not all rectangles, right? You guys? Alright, so what will be the M6? What is delta x each time?
0.25.
Delta x means what? It learns for this subinterval, right? Should be, let's use this way. B minus A divided by 6 subinterval. Let's compute it. 3 out of 6 is what? 0.5, okay? So delta x means the width for each of the rectangle will be what? 0.5, right? We only need to find the height, right? For height. So on this subinterval from -1 to -0.5, what is the middle point? What is the value for the middle point? What is it? What is it? -0.75. Ooh, so f of -0.75 will be the height. Because eventually I want to use, I have a red pen here with me. Yes, I do. So, alright. So midpoint, we have this rectangle, okay? This rectangle. The height is f of -75. What is the width? 0.5, right? Times 0.5 plus, in this subinterval from -0.5 to 0, what is the middle value, middle point? From -0.5 to 0. -0.25, right? -0.25. So I would say f of -0.25 times by what? Still 0.5, right? Every time 0.5 plus this subinterval middle point is what? 0.25, right? Okay. F of 0.25 times by 0.5. Similarly, between 0.5 to 1, what is the middle point? 0.75, right? From 1 to 1.5, 1.25 times 0.5. 1.5 to 2, 1.75 times by 0.5. Woo! That's a lot of work, right? It's a lot of work. Okay, however, see, every term has multiplied by a 0.5, right? So we pull this 0.5 out, right? 0.5 out. Yeah, so eventually we're going to multiply the thing by 0.5, right? 0.5. So f of 1, -0.75, what is f of x? 1 plus, right? So 1 plus -75 squared. This is f of -75. What is f of -0.25? 1 plus -0.25 squared. This is what? 1 plus 0.25 squared. 1 plus what? 75 squared. 1 plus 1.25 squared plus 1 plus 1.75 squared. Ooh. It's very tedious, right? So inside of the bracket, we just need to add up all of these. You can use your calculator. Yeah, and then eventually times by 0.5. So we should have an answer. Something. Yeah, do it, please. Do it. -0.75, you can consider this 0.75, okay, because it's a square. -0.25, it's the same as 0.25 square. 0.25 square. Oh, what is this? 0.75. Sorry, it's not 75, okay? And this is 1.25, this is 1.75 square. And then you can add 1. Okay, there's 6 of the 1 together, right? Anybody has an answer? Grant, what do you got?
I got 95 over 32, but I did it in a slightly different way, so I might
95 over 32.
put you over there.
I don't know. So 6 plus, let's do it that way. They're actually double of the 0.25 square, double of the 7.75 square, right? So 0.75 times 0.75 times 2, I would say 1.125 plus, did I use 75, right? So let's use 0.25 times by 0.25 times 2, double it, 0.125 plus 1.25 square, oh my, 1.5625 plus, this is 1.75. Okay, and then add by 5625 plus 0.125 plus 0.125 plus 6, and then times by what? 0.5? 5.9375. Do I get the same answer?
No, I don't. That's what I got.
That's you, what do you got? Okay, so,
Can you tell me where I went wrong on this?
yes,
So I